Hey everyone, my name's Ishan, and today I'm going to be teaching you about natural deduction, specifically the rules in natural deduction, and kind of making them more concrete so that it's easier to follow along. So let's dive in. So as you probably know by now, these are the natural deduction rules, and you don't need to memorize these, but it's good to have them on your cheat sheet or somewhere on hand so that you can reference them as needed. What's not, you don't need to memorize them again, but you do need to know how to apply them. And today we're going to be breaking these into groups and just understanding them slightly more concretely than we did in class. So the first set that we have here is the more basic ones, and intros or intros and limbs. Yeah. So let's think instead of P and Q, that's kind of arbitrary. So let's kind of think of some examples of what propositions can be. So for P, let's say, actually, let me change my color. Just so it's easier for you guys to see. Let's say P is the fact that I like chocolate. And in case you're wondering, P is very true. I love chocolate, and it turned out to be unfortunately true this quarantine. And now let's say Q is that I am wearing blue socks. So I am wearing blue socks. Okay. So now let's look at each of these rules and see what we can conclude knowing a few premises. So let's say that I know P. I know that I like chocolate, and I know Q. I know that I'm wearing blue socks. What can I conclude? That's right. I can conclude that I like chocolate and I am wearing blue socks. In other words, P and Q. And that's really the basis of the and intro. The and a limb is really similar. If I'm telling you that I like chocolate and I'm wearing blue socks, you can automatically conclude that I like chocolate. The or intro is a bit different, but not very. So we can say that if I like chocolate, what can you tell me? You can definitely say that I like chocolate or I am wearing blue socks. Because remember this or operator, it doesn't say either or, it says P or Q or both. Either I like chocolate or I am wearing blue socks, or both I like chocolate and I'm wearing blue socks. And we can definitely conclude P or Q using this or intro. Now let's take a look at this negate not a limb. So what is not P? It's kind of a double negative. It's like saying I don't not like chocolate. Let me repeat that once again. I do not like chocolate, which is kind of weird to think about if you think about it. Why not just say I like chocolate? And that's essentially what this double not a limb is doing. It's converting I don't not like chocolate into I like chocolate. As for this not a limb, this is saying that if I were to say that I like chocolate and I do not like chocolate, then I'm lying to you. Something here has to be false. And one thing to note about for this not a limb is that you usually don't use it outside of an assumption box because then you kind of don't really have any valid proof. If I were to say P and then not P and just conclude false, then I haven't really proved anything. But as we'll see later on, let's say I had P and Q. Then in an assumption box, I put and then I concluded P from my and a limb, and then I assumed not P. I could show that this has to be false. And yeah, as I said before, usually this not elimination is within a assumption box. I wouldn't worry too much about that just yet. We'll get to assumption boxes and overall proof strategy a bit later. Now let's look at the implies and biconditional implies statements. So we're going to use a different example for P and Q. Let P be the water is green. The water is green. And Q be that there is algae in the water. So algae is in water. And I'm telling you that if the water is green, then the algae is in the water. So if I see that the water is green, as we see in this implies intro here, even if I'm just assuming that's the case, and I can directly conclude from that reasoning that there is algae in the water, then essentially I haven't proved much besides an implied statement, which is exactly what we're introducing here. We're saying that assuming that the water is green and ignoring all external conditions, then if you can conclude algae is in the water, then you have effectively shown that the water is green implies that there's algae in the water. And this double biconditional implies intro is really similar to that. If I can go from the water's green to there is algae in the water, and also vice versa, from going from just saying there's algae in the water to the water is green, then I can say that the water is green and the algae is in the water biconditionally imply each other. What about implies elimination? So if I'm telling you if the water is green, then there is algae in the water, and I also tell you the water is green, what can you conclude? You can definitely say that there is algae in the water. And that's exactly what we're doing here. We're saying the water is green. If the water is green, then there's algae in the water, and the water is green. The biconditional implied statement is really the exact same thing. Okay, now here's a bit of a trickier one, or elimination. So just by looking at P or Q, how do you conclude R? That's something that's entirely different. And in order to do that, I think, again, let's look at it through the lens of an example. Let's say that I am on Central Campus. I have to get to my EECS 203 discussion on North Campus. In order to get to North Campus, I can either take Bursley-Bates or commuter north. So let's say P is the fact that I take Bursley-Bates. Bursley-Bates. And Q is the fact that I take commuter north. By the way, this may or may not be inspired by a true story. So I either take Bursley-Bates or I take commuter north, P or Q. And I'm thinking to myself, how can I best get to my class on time? And I say, okay, if I take Bursley-Bates, then I know that I will be late. So R is I will be late. And I'm looking at double map. Actually, I guess it's not double map anymore. And I think if I take commuter north, then I will still be late. And that's essentially what these assumption boxes here are saying. If I take Bursley Bates, I will be late. And if I take commuter north, I will be late. So just looking at the logic of this, what can you conclude? Well, I'm definitely going to be late. And so while these math symbols might not seem intuitive, in reality, if you think about it in terms of concrete examples, it really does start to make sense because I have these limited number of options and they all lead to the same outcome. In other words, I'm going to be late for my EX 203 discussion. Now let's move on to and intros and false limbs, which are probably two that students confuse the most. And I can definitely see why. You have a false leading to a not statement, and you have a false leading to a true statement, and it's kind of hard to wrap our heads around this. So let's go a bit into the theory behind it first. So a not intro is used when you're assuming P, and again, P can be any statement. We'll use a concrete example in a bit. You conclude that from P that you arrive at a contradiction. What can you conclude? Not P. Now, this false elimination, it's actually not drawn very well. This were, usually we don't make false eliminations outside of an assumption box. So this will be like saying we have P, we assume not P, and we have, based off of that, we have false. And so essentially I can conclude whatever I want, whether that's Q, yeah, so first of all, how do we get to this false? It's by the rule we looked at earlier. Remember, this was the not elimination. So right here, we see the P and not P lead to a false. And now coming back here, now that we've reached the false, what can we conclude? Well, in reality, we can conclude anything because if this assumption box is false, then we can conclude Q, for example. But what's important to notice here? You have to remember that right here, let me use a different color again. Right here, this Q is staying inside the assumption box. Whereas right here, this P or this not P is coming outside of the assumption box. And this might seem a bit theoretical, but again, let's dive into an example. And this is might seem like a highly contrived example, but just bear with me. Let's say that P is I go time travel into the past and kill my grandfather. So I'm going to shorthand this TT to past kill grandpa. And sorry, Lakshman, but I guess you're dying in this example. And we're going to say that Q is that I'm wearing blue socks. Wearing blue socks. So let's say that, let's assume P. let's assume that I time travel to the past and I kill my grandpa. Then my mom is never born, and then I am thus never born. And then I can't time travel to the past to kill my grandpa. And essentially, we've arrived at a contradiction. Let's put this back into terms that, in natural deduction terms. I am assuming P, that I time travel to the past. I do a series of statements like, I kill him, he can't give birth to my mom, and now I cannot time travel to the past to kill him, aka not P, which leads to a false conclusion, because again, you can't have P and not P. What does this lead to? We can say that, okay, well, that just means that you can't time travel to the past and kill your grandpa, right? And that's what we're essentially bringing out here. Because if P leads to a contradiction, if time traveling to the past means, and killing my grandpa means that there's a contradiction, then that means I cannot time travel to the past and kill my grandpa. But now let's look at a similar example. Let's assume P once again. I'm time traveling to the past, killing grandpa. My mom isn't born. I'm not born. I can't time travel to the past. Da 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 da. So far, this looks really similar to what we had before, right? Now, I want to ask you, can I conclude that I am wearing blue socks? Now, you're probably wondering, wait, what? Where did wearing blue socks come from? You can't just conclude that out of nowhere. And so you can't really conclude it, but what we're saying is that you have this alternate reality, this assumption box, where I can time travel to the past to kill my grandpa. And because this alternate reality, this assumption box, makes no sense, I can write whatever I want inside the assumption box, regardless of whether or not it's true, because as we concluded from here, this false statement, nothing about this assumption box is really has to be true. It's just nonsensical. So based off of this, again, remember, not intros are when you're concluding exactly the opposite of what you started with. So let's use one last color. I'm saying P and I'm getting to not P. And based off of that, I can leave the assumption box. But if I'm going from P to Q, then I have to be in an assumption box. And noteworthily, you can conclude based off of this false elimination that P implies Q. But you can't necessarily conclude that I am wearing blue socks. So that's all we have for you today. I hope that this helps really understand the building blocks of natural deduction. And if you have any questions, again, feel free to email us, use Piazza. We look forward to hearing from you.